Now our digital to 0 to 10 volt adapter should be capable of taking a number of different current supplies, in other words a range of constant current source in, and still reliably drop a control voltage across these two terminals that represents the digital level that's being transmitted by the switch to the adapter. As you will recall, the actual control voltage in a 0 to 10 volt system is produced by the device that is receiving the voltage drop as a command. This voltage is produced across the terminals of a constant current source, and these lines, when you combine them for different ballasts, will add up. Each of these little branch circuits will add up, and therefore, if I put in 10 0 to 10 volt luminaires, I would expect to see 10 times the current on these lines that I would if I had only put one in. In fact, we have one ballast here in the office or in the shop that has a 200 microamp output, and we have another one that has about a 1.2 milliamp output, which is about 6 times. So under either condition attached to our adapter, we would expect to see the adapter reliably putting some sort of a voltage drop across these two lines.
There you are, sir. I think that has it. Have a look at it.
Hey, I just noticed this video is a couple of minutes longer than I thought, so we better fill it up with something. I'm going to test some 0 to 10 volt ballasts on our new DALI test set. So this is a Philips Mark 7 0 to 10 volt dimming ballast, and we're going to check its open wire voltage, so there's no load on these wires. Typically any small load will bring you down to about 10 volts. We got 13 1/3 for the open wire voltage on this ballast. We can see we can test it by shorting it together. It's got a fairly long fade rate and a bit of a bounce at the bottom where it goes boom. It comes back up a tiny tad bit. So we should be ready to go, hooking it up to our 0 to 10 volt output on our DALI test set. Now this is just a single ballast, but we're going to check its current on its control leads. And I've got about 200 microamps. Alright, we're hooked up and we're monitoring the control voltage and the light meter. Should be able to see that the lights are indeed reacting with that slow fade rate. And so everything is hunky-dory for testing. So we'll just come in here and take a few readings, and we'll note that the first time we hit a dimming level, we dropped down to about 7.73 volts. We can expect the control voltage is going to be rather consistent, but that the dimming is going to be a little on the weird side. Maybe a little on the weird side being an understatement, because this is 0 to 10 volts. So I'll let you know how this turns out. Okay, we're using a Lume Energy ballast that actually came with this stuff, but we've broken it out so we can get to its 0 to 10 volt inputs. This ballast will take DALI or 0 to 10 volt, and we know it's working, and we also note it's a European ballast, so when I short the control lines, it goes out, right? So now let's have a look at its open wire voltage. We always want to check that. This is a single ballast, right? And I've got open wire of 14.2-ish and open wire current of about more than the American ones. I'm pretty sure about that. I'm going to go to 2 milliamps. And we check it and we see, yeah, we got a bunch. We got like 1.1516 milliamps. So the current driver in this ballast is got 10 times the current output, basically, of our other two Phillips ballasts that we looked at. Always interesting to note that. Alright, we're hooked up. We're monitoring control voltage and output from the luminaire, and we can see that this is working just fine, and that our control voltages, as we may have expected, are fairly consistent with what we got using the other two ballasts, because the 0 to 10 volt current sinking control has one job in life, and that's to put a consistent voltage across the 0 to 10 volt control lines based on what it's been told to put out. Interesting to note, however, that this is a European ballast, and so if I hit the off control, it's going to short the control lines and actually put it out, and that's really handy. So what I'm going to do is I'm going to get some readings, and we'll take a look at this when we're done with the whole thing.
So we'll take a look at some waveforms and this data in the next video.